In the dim underbelly of North America's eastern wetlands, where soil merges seamlessly with shadow, a creature stirs. It emerges not with grace, but with an insistent probing, an appendage that defies the familiar contours of life on this planet. 11 fleshy rays, radiating like the arms of some forgotten sea star, pulse and quiver in the murk. This is no relic of the ocean depths, no artifact of ancient tides. It is the star-nosed mole, Condylura cristata, a mammal that navigates a world we can scarcely imagine. And yet, as it tunnels through the sodden earth, one cannot shake the sense that nature has overstepped, crafted something too precise, too alien for the terrestrial realm. Imagine, if you will, a landscape perpetually shrouded. The lowlands of eastern Canada and the northeastern United States, where rivers carve through peat and fog, clings to the ground like a veil. Here, light is a stranger. The soil is a labyrinth of perpetual night. In this realm, vision is obsolete, a luxury discarded by evolution's unyielding hand. The star-nosed mole, blind to the world above, has instead forged a sensory organ that borders on the unnatural, a nose not for scent, but for touch, amplified to an extremity that challenges our understanding of mammalian limits. At first glance, the star might appear as a grotesque flourish, a mutation frozen in time, but observe it in motion. Each of the 22 tentacles, 11 on each side, undulates independently, scanning the environment with a rapidity that evokes mechanical precision rather than organic whim. These are not mere whiskers or feelers. They are Eimer's organs, densely packed with over 25,000 mechanoreceptors, nerve endings so sensitive they detect the faintest seismic whisper in the soil. In the star-nosed mole's domain, prey does not hide. It is mapped, dissected by touch alone. A worm's subtle coil, the infinitesimal tremor of an insect's leg, all are laid bare.
What drives such an adaptation? Consider the pressures of this submerged existence. The mole's habitat is a flux of water and earth, where floods reshape tunnels and prey scatters in unpredictable swarms. Survival demands not patience, but velocity, an ability to seize opportunity in fractions of a second. Evolutionary logic points to a relentless arms race. Predators like owls and foxes lurk above, while below, competition for scarce, fleeting meals intensifies. Over millennia, natural selection has sculpted this nose, favoring those whose appendages could probe faster, feel deeper. Yet this refinement comes at a cost. The star consumes a disproportionate share of the mole's neural resources. Nearly a third of its somatosensory cortex is devoted to processing these tactile signals, a trade-off that leaves less for other senses, binding the creature ever tighter to its shadowy niche. Watch as it hunts. In laboratory observations, the mole encounters a potential meal, a small earthworm segment perhaps, and the star erupts into action. Tentacles fan out, retract, assess in a blur of motion. Identification and consumption occur in under 200 milliseconds, a feat that crowns it the fastest forager among mammals. This is no casual graze. It is a predatory strike honed by environmental exigency. In the wild, amid the sodden banks of a stream, the mole swims with seal-like efficiency, its star probing the currents for aquatic larvae or crayfish. But herein lies the unease. Such speed, such specialization feels engineered rather than evolved, as if the mole has bypassed the gradual tinkering of nature for something more deliberate, and yet, this is only the surface. The star-nosed mole's adaptations extend beyond mere hunting. They reshape its very interaction with the world. In winter's grip, when ice encases the wetlands, it tunnels beneath frozen layers, its nose detecting thermal gradients or the minute vibrations of hibernating prey. One leading theory posits that the star's sensitivity allows it to see through touch, constructing a tactile map akin to echolocation in bats, but silent, intimate, unnervingly direct. The trade-offs deepen. This hypersensitivity exposes the mole to overstimulation, a barrage of signals that could overwhelm in less controlled environments. Evolution has gambled here, betting on extremity for survival in a habitat where moderation means extinction. As we delve further, the abnormality intensifies. The mole's brain, disproportionately enlarged in regions governing the star, suggests a neural architecture skewed toward obsession, a single sense dominating all others. What happens when this creature ventures beyond its watery confines? Or when environmental shifts challenge its precarious balance? These questions linger, drawing us toward revelations that unsettle the boundaries of what we deem natural. The abnormality does not end with the star itself. Beneath the surface, where the mole's world contracts to tunnels of mud and water, another layer of strangeness unfolds. This creature has mastered something no other mammal achieves with such effortless grace. It smells underwater. In the flooded chambers of its burrows, or along the shadowed beds of streams, the star-nosed mole exhales tiny bubbles, brief, deliberate bursts that carry scent molecules from the surrounding water back to its nostrils. These bubbles collapse and reform in rhythmic cycles, allowing the animal to sample chemical traces without ever surfacing. What appears as a simple breath becomes an act of sensory trespass, blurring the boundary between air and liquid respiration. No other terrestrial mammal has evolved this capacity so completely. It is as though the mole has borrowed a fragment of aquatic life and grafted it onto its mammalian form. The star, already overloaded with tactile information, now serves as a conduit for olfaction in an element hostile to lungs and fur. This dual existence, equally at home in saturated earth and open water, demands further compromises. The mole's body, dense and insulated, maintains a high core temperature even as it plunges into icy currents. Its forelimbs, broad and spade-like, propel it through water with the undulating motion of a seal, while the star probes the substrate for larvae, small fish, or the faint electrical whispers some researchers suggest it may detect from hidden prey. Yet this versatility exacts a price. The energy required to sustain such rapid neural processing and constant motion leaves little margin for error. The mole must consume its own body weight in food daily, or more, devouring prey items in as little as 120 milliseconds. To falter is to starve in a habitat where abundance is illusory. Small invertebrates swarm briefly, then vanish. Observe the neural architecture that underpins this existence. The somatosensory cortex expands dramatically to accommodate the star, with entire modules, visible bands of tissue, dedicated to each ray. The 11th appendage, the tactile fovea, commands an oversized representation, much like the magnified visual field in a primate's eye. This is no balanced brain. It is a mind reshaped by obsession, where touch eclipses sight, sound, and scent in priority. The mole constructs its reality not through distant observation, but through intimate, relentless contact. Every surface mapped, every vibration cataloged. In this hyper-specialized neurology lies an unsettling implication. Evolution has not merely adapted the animal, it has rewritten its cognitive priorities, turning a single sense into the axis around which survival turns. Yet even this extreme design reveals vulnerabilities. The star-nosed mole, for all its prowess, remains tethered to fragile wetlands, peat bogs, marsh edges, slow-moving streams now vanishing under drainage, development, and shifting climates. Its semi-aquatic tunnels flood or dry with alarming speed. Its prey cycles with seasonal unpredictability. Predators, owls silent above, fish lurking below, mustelids slipping through the undergrowth, exploit any lapse. And in winter, when ice seals the surface, the mole persists beneath, tunneling through frozen layers, its bubbles still rising in the cold dark. What emerges from these depths is a portrait of life pushed to its limits. The star-nosed mole does not merely survive its environment, it embodies the cost of dominating it. A creature engineered for speed, sensitivity, and submersion, yet forever one environmental shift from obsolescence. In its ceaseless probing lies both triumph and fragility, a reminder that nature's most astonishing inventions often balance on the narrowest edge. As we withdraw from these shadowed realms, one final question lingers in the quiet. If such extremity can arise in a humble wetland dweller, what other boundaries might evolution quietly cross, unseen, in the places we rarely look?